Take a look at these last type of factoring now. Problems 1 and 2, just kind of do a spoiler alert. These are ones that are like what we talked about in the last video where we're unfoiling and we're figuring out what two binomials, will multiply to do this, thinking in terms of FOIL or the reverse of FOIL. 3 and 4, we're going to unfoil those, but on 3 and 4 we have other issues that have to be considered when we go through this quote-unquote unfoiling process. All right, so let's take a look at problem 1. Now, the proper way to approach any factoring problem is first look for the greatest common factor. The greatest common factor is 1. Okay, now, the fact that this is a trinomial, not a binomial, don't ask, is it the difference of two perfect squares? So we're not thinking about conjugates here. We're saying, okay, yeah, it's not the difference of squares, we move on. But could it be a perfect square trinomial? And the number 30 is not a perfect square, so forget that. Right, so we say, okay, this is going to be an unfoiling process if it's going to be anything at all. Right? Because we're not 100% sure that it even factors. And again, if it doesn't factor, we just write prime down. But we better make sure that it doesn't factor if we're going to write that. Okay, with the unfoiling process, what we put in the f of FOIL, the first slots here, have to multiply to be x squared. Right? And, x times x is x squared. What we put in the L of FOIL has to multiply to be 30, and that's what I said. That's kind of the problem. I can't just start writing numbers in. Anything that multiplies to be 30 is good. We have to be careful. Not only does it have to multiply to be 30, the numbers I put here and here, but it also has to add, I should be careful, it has to multiply to be positive 30, yet add be negative 11. Now you're thinking, what multiplies to be positive 30? Well, if you're thinking two positive numbers, those multiply to be positive 30, that's very true, but they're never going to add to be a negative. So we have to be thinking in terms of two negative numbers. A negative times a negative will be positive, but it will add up to be a negative. So let's think in terms of negative values here. So what multiplies to be positive 30, yet adds to be a negative 11? Again, you can list out the factors of 30, thinking negative 1 times negative 30, negative 2 times negative 15, negative 3 times negative 10, negative 5 times negative 6. There's 4 potential candidates, right? They all multiply to be positive 30. Now, the reason I'm not writing two positives, as I already said, they're not going to add up to be a negative. Two positives can't add up to be a negative. These are my only options. So any of these 4 add up to now be negative 11. The answer is, well, yeah, negative 5 and negative 6. So negative 5, negative 6, and it wouldn't matter if you wrote negative 6 and a negative 5. It's the same thing, it's just you're switching the binomials around. So that is how that polynomial factors. Okay, look at problem 2. First thing, greatest common factor. This time we do have a greatest common factor other than 1. It's 3x. We factor out the 3x and we undistribute. Right? Divide the GCF into each of these terms, giving you x squared plus x minus 20. Right? Now, again, you're done with the 3x. You don't factor monomials. But what you could factor is what's left over. So don't just do one factoring step and say, well, I'm done. Check to see what's left over if it doesn't factor any further. X squared plus x minus 20 has potential. Right? So it's a trinomial. First question I'd ask, is it a perfect square trinomial? And the answer is, well, no, because that's, first of all, negative, so forget that. Next, does it unfoil? Maybe yes, maybe no. Well, let's take a shot at it. If it's going to unfoil, that would have to be x and x. Now again, what multiplies to be negative 20 is going to be a positive and a negative for sure, but then it has to add up to be not 0, it has to add up to be a positive 1. That's what you got there. So what are all the factors of negative 20? Numbers that multiply to be negative 20, but then add up to be a negative 1. And the answer is, well, a negative 5 and a positive 4. Negative 5 multiplied to 4 gives us our negative 20. Negative 5 added to 4 gives us our, negative 1. We want a positive 1. That's why it's a good idea to check those. Good thing I caught that. So positive 5 added to a negative 4 is a positive 1. Oh, yeah, let's not make another mistake here. Don't forget your greatest common factor. So that's the proper factorization of the original trinomial there. So look for your GCF first. That's always your first goal. If it's a binomial, look for difference of squares. If it's a trinomial, see if it's a perfect square trinomial. If not, do the unfoiling. And, you should systematically factor these things. All right, the tough ones are 3 and 4. And these are tough because of this coefficient in front of the x squared. That does muddy up the waters when we go to unfoil this. Now again, you can go back to that x method that I was kind of referencing in the other videos. I never remember how the numbers go because that's never how I factor these. I always factor them by unfoiling because that's the process that kind of makes sense in my head. The X method is okay. It's a little convoluted in that you have to go through steps of factoring by grouping where you're splitting up these terms. It's not a bad process. It's just it requires you to remember those steps. And like I said, unfoiling doesn't require me to remember steps, just to check answers. All right, so when I go to factor number 3, first thing I look for is my GCF, right? Because I had an issue there here. There was a 3 in front of there. But when I factored out the GCF, we were back to a 1, which made things nice. So in this case, the greatest common factor, unfortunately, is 1. I say unfortunately because that means that this is going to be a tougher polynomial to factor, right? Unless, of course, it's a perfect square trinomial, but 6 right away ruins it. So next thing I do is I go to unfoil it, just like I did for this problem right here next to it. Right? And I'm going to ask the same question. What multiplies to be 6x squared? Well, the problem is there's 2 options now. Over here I just said what multiplies to be x squared? It's x and x. There are no other options. But here, it could be an x times a 6x, or it could be a 2x times a 3x. Now the question is, which one is it? The answer is, I don't know. What we're going to do on these is we're going to guess and we're going to check. We're going to guess the factors that guarantee the F and the L of FOIL work, and then we're going to check to make sure the middle works. So it's not going to be so obvious like we had on these. Now, to make your guessing life a little bit easier, most of the time I find out on these that the factors that are closest together are usually the ones that work. So you got 1 and 6, 2 and 3. 2 and 3 are closer together than 1 and 6. So just by guessing, I'm going to go with 2x and 3x as a first guess. All right, now we still have to guarantee the L of FOIL, so we still got to get the F of FOIL. We got to get 6x squared when we FOIL this out. That will give us the F. Still got to get a negative 5. That'll be the L. Now, for negative 5, you don't have many options. You got these two. That's it. Those are the only factors of negative 5. Now, if you're looking at these and say, well, none of them add up to be negative 13, it's a different ballgame now. Here we had a 1 in front of the x squared. Here we have numbers that are multiplying to this 1 and 5 to create this negative 13. It's a little bit more complicated. So don't just say, well, none of these add up to be negative 13. That's not the issue, because they have to multiply to these as well. So as far as these are concerned, don't sweat too much whether one's positive or one's negative, or which one has to be positive, which one has to be negative, because they're just going to give you opposite answers for your middle term. But what we do have to guess is, does the negative 1 go with the 2, forcing the 5 with the 3? Or is it vice versa? Does the 5 go here and the negative 1 go there? And it does make a difference, not for the F and the L, but it makes a difference for the outer and the inner. So this is where the checking comes in. We're guessing on these numbers. We know that the F and the L work, but does outer and inner actually add up to be negative 13? So if you do outer here, you get 10x. If you do inner here, you get negative 3x. Adding these two guys up, 10x and negative 3x is 7x, which means the negative 1's not going with the 2. So what I do is I set this up again. Let's put the 5 with the 2 and the negative 1 with the 3 and see how that works. Now check outer and inner. Outer this time is negative 2x. Inner is 15x. 15x minus 2x is positive 13x. What that means is, since I want a negative 13x, I got the signs wrong. In other words, this needed to be minus and that needed to be plus. Because now outer becomes positive 2x, inner becomes negative 15x. Right? So it's a matter of adjusting, first of all, where the factors go, and then adjusting the signs to get the proper factorization through our FOIL. Right? It is a process, I'll grant you that, but this X method is just as much, if not more so, of a process. Okay, so let's kind of try out our stuff on this one. Again, greatest common factor is 1. It's not a perfect square trinomial. What are the possibilities for 24x squared? Well, you got x and 24x, that's for sure. You got 2x and 12x. You got 3x and 8x. And you got 4x and 6x. Again, it's been my experience that the factors that are closest together tend to work. So I'm going to try 4x and 6x. Okay, same thing with the negative 15. You got options here. That's negative 1 and 15, negative 3 and 5, and of course the opposites. And what I said is don't sweat the signs, because you saw in the last one I had to adjust it. I didn't know if it was 1 and negative 5 or negative 1 and positive 5. It just, you had to adjust it. So again, I'm not going to sweat it. One's going to have to be negative, one's going to have to be positive. Now here we can use a little bit of strategy, and that is, when I pick the ones that are closest together, which I'm going to do here, I'm going to go with 3 and 5. Now, here's the thing. I know for a fact 3 cannot go here. And it's not because I know what the answer is. It's because I see that the GCF, if I put a 3 here, would actually be 3. And that's a problem. It's a problem because the GCF of the original would have to be 3 if that were the case. So if you create a binomial that has a GCF other than 1, it can't work, because we've already checked to see if the GCF was 1. So what I'm saying on this one is we'll put the 3 here and the 5 there. Again, I'm just guessing the signs. We'll see if that works, right? This is my first guess. Now, I'm just checking the outer and the inner of FOIL. I'm not worried about first and last because I know those work. That's why I'm guessing these actual numbers here. Those guarantee first and last work. It's outer and inner. So outer here is negative 20. X, inner is 18x. And if you notice, that does give me a negative 2x. I wanted a positive 2x, which means I only messed up the signs. All right, so that's negative 18. That's positive 20. And that's actually how it factors. All right, we'll practice more of these during class. They are the tougher ones.